Okay, everybody, this is section 3-4, part 2. So we're finishing up our idea about inverses. So I'm going to go through and talk about a few more of these. Now today we're going to pick up more with the rules again, the equations. How do you find the inverse, and is the inverse a function? So remember, to find an inverse, you switch the x and the y, the domain and the range. All right, so think about this original function. So f of x, it's 2x squared plus x minus 3, which would be what kind of a graph? A parabola. So think of our horizontal line test that we talked about yesterday. This parabola, if we passed a horizontal line, would touch 2 points every single time, which means when we find f inverse, it's going to be a parabola opening sideways, which would be a vertical. So it would not be a function. Alrighty, so that f inverse clearly is not going to be a function, so that's a no, because we know what's going to happen when we do that horizontal line test that we were talking about in part 1. So the horizontal line on the original makes it a vertical line on the inverse, which wouldn't be a function. Okay, so let's take a look at what you'd have to do this one. You're going to interchange the x and the y. So in this case, that means everywhere there was an x, there has to be a y. Now, technically, that's the inverse equation. We know it's not going to be a function. This would be really hard to solve for y, though, convenience sake. So the work that you would have to do to solve for y, we're not going to do it right now, would be completing the square. So, I mean, we can do it. It just takes a little bit of time. So we don't want to take the time right now. We're trying to focus in on the inverse part, but you could definitely solve for it and get that inverse. Okay, a few more examples to finish up with. So let's find the inverse for this one, first of all. The original equation's linear, which means think of the horizontal line test. The inverse will have only 1 point, so the inverse of this should be a function as well. We're going to switch the x and the y, and we're going to solve for y. Just be really careful when you do that. So technically what I just wrote in blue, that is the inverse. Okay, so now I'm going to add 4. And now how do you get rid of timesing by 2/3? Easiest way, multiply by 3/2. Okay, so don't try to divide by a fraction. That's terrible. Multiply by the reciprocal, but now just be super careful. Distribute, right? So that would be 3/2 x plus 2 divides into 4 twice. That would be 6. So just be really careful. So here's the inverse. We get a linear equation, and the inverse most definitely is a function. It's a slant line. That would definitely be a function. Just be careful when you solve for y. Okay, a couple more. So x to the 5th minus 3. Okay, so for this one, think about your parent graph. X to the 5th looks something like this. The minus 3 shifts it down 3. So think of the horizontal line on the original, only touching 1 point, right? So when you do the inverse, it'll be a graph kind of going across like this. The vertical line will only touch 1 point. So the inverse will definitely be a function. All right, so let's switch the x and the y. And then again, that is the inverse. The blue is the inverse, but let's solve for y. Convenience again. So we add the 3. And then how do we undo raising something to the 5th? Well, we take the 5th root. So y equals the 5th root of x plus 5, or 3, sorry. So think about this. Do you need a plus or minus on a 5th root? Well, no, because it's an odd-powered root, so we don't need to worry about that. Let's talk about that transformation piece of this that we did before. So that's why this one's going to be a function. There's no plus or minus. All right, what was the transformation on the original? The original graph went down 3, so 3 in the y direction. Take a look and see what's happening there. That would be a left 3. So what was down, negative in the y direction, becomes a negative in the x direction when you do the inverse. So it's going to always have that relationship. So whatever it was with the x will be with the y. So you can almost predict what that's going to look like. Okay, our last one with the rules here. We'll talk about writing the equations. When you graph this one on your calculator, you get a very interesting looking graph. We're going to talk about these rational functions some more in the next chapter. But for now, let's just try to see if we can do an inverse. So if you graph it on your calculator, take a peek and see if you can tell what it looks like. I believe it makes sort of like a funnel sort of shape, which means it's going to touch more than 1 point, so the inverse won't be a function. We'll see why that is in just a second, but let's find the inverse. All right, so we switch the x and the y. This one's a little bit more complicated to solve. I almost think of it like a proportion. We need to get the y out of the bottom, so you can cross multiply, think of it that way, or just multiply both sides by that denominator so we can get that y out of the denominator. So it cancel over there. That would be equal to 4. So we have y minus 1 squared times x equals 4. Okay, we're trying to solve for y. This is all the convenience part now. Let's get rid of the x. So we get y minus 1 squared equals 4 over x. Now we're going to undo squaring. Be careful when you do this. The little bell should be ringing in your head here. Plus or minus. So y minus 1 equals plus or minus, and then add your 1. So we would have plus or minus the square root of 4 over x plus 1. Plus or minus means my inverse is not a function. So I started off with something squared, I end up with something square root, definitely not a function. So sometimes the solving for y can be a little bit trickier, but that's what we need to look at to be able to find that inverse. So to be able to work with it anyway. So switch the x and the y, solve for y, inverses. And remember what symmetry these graphs always have, y equals x. Alrighty, so that wraps up our kind of part 2 here for inverses.